Hello, lovely formulators. This is Elam from Skin Chakra, and today I'm going to talk to you about the emulsion viscosity, its impact on the stability and properties of the emulsion, and how we can manipulate it without a negative impact on the stability. But first, we need to have a clear definition of the viscosity, and the most basic definition is that viscosity is the measure of the internal flow resistance of a fluid. What the hell does that mean? Let me explain it with a simple experiment. Imagine we have three containers, exactly the same shape and size, and we fill them with three different liquids to the same amount. We put three balls, metal balls for example, exactly the same shape and size. So everything in this experiment is exactly the same except the nature of the liquid in these containers. We have here liquid number 1, liquid number 2, and liquid number 3 with my beautiful handwriting. So in the first container, the metal ball sinks very fast. In the second, it sinks rather slowly. And in the third, it sinks even more slowly or very slowly. So the difference in these three containers is mainly the viscosity, or is only the viscosity of the liquids. And obviously the third one has a higher viscosity, so that the liquid or the resistance to flow is more, and this metal ball sinks more slowly or slowly to the bottom of the container, whereas here where the viscosity is low, the resistance is low, and the metal ball moves very fast. As primitive as it may look, believe it or not, this is the method that they are still using in the industry and in the real world to measure the viscosity and compare the viscosity. It is very often used in the paint industry, glue, and varnish and oil industry, and they obviously use automated systems and computerized systems, but the principle is the same, and this method is really used in the industry. The viscosity of an emulsion can vary anything between a very thick cream or emulsion, as you can see it here, that you only can fill in a jar or in a tube, to a rather medium viscosity that you can fill in a bottle and pour from the bottle or apply from the bottle, or a very low viscosity, which is a sprayable emulsion. So the viscosity range can vary from a very low viscosity sprayable emulsion to a thick cream. Necessarily there is no better or worse, so there is no general rule to say high viscosity emulsions are better. It actually depends on the concept and on the purpose of the product. But I have to confess that for social media and your videos and photos, the high viscosity emulsions look prettier, sexier, attractiver compared to medium viscosity emulsions. But from a technical point of view, an application point of view, it is no general rule that which one is better. It all depends on the purpose of the product. But the general rule is that it is easier to stabilize a high viscosity emulsion compared to a low viscosity emulsion. And that is because you have to look at an emulsion as a dynamic system, not a static system, where these small particles are permanently moving around, colliding together, and building bigger particles. This is called coalescence, if you have seen or read about it somewhere in an article. And this is the process that finally causes creaming and phase separation and emulsion instability. And this equation, which is called the Stokes equation, is a mathematical equation that predicts the velocity or the speed that these particles move around and collide together. This is the speed. And depends on the viscosity of the liquid or product and the particle size. So you see here that the speed that these particles move around, collide together, depends on the viscosity and the particle size. And we can generalize it that the bigger the particle size and the lower the viscosity, the stability is lower because the speed of collision between these particles is higher. So this is a general rule, and this is why I told you that it is more difficult to stabilize low viscosity emulsions compared to the high viscosity emulsions. Why this is important? Because based on the viscosity of the emulsion that you are making, the manufacturing procedure, machinery, storage, filling pumps, packaging machines and pumps, and application mode all depend on the viscosity of the emulsion. The first three factors perhaps are not quite obvious for you if you come from a small scale and make small batches in your atelier or artisanal lab. But the packaging and application mode you can even observe in the small scale. The first three factors make a huge difference in the mainstream industry when they are moving around and working with tons and tons of liquid. So the kind of machinery, the filling machines, the pumps, the storage, all of that depends on the viscosity of the emulsion or the liquid that they are working with. Keep in mind that when we are making emulsions, the emulsifier is actually the king. So a huge amount of emulsion properties, even the type of the emulsion, are predefined by the emulsifier. So there are two main approaches to making an emulsion. Either you have an emulsifier at hand, let's say you have received a sample from a supplier, or you are interested in a kind of emulsifier or read about the emulsifier in a blog post. You take that emulsifier and you go create an emulsion that matches the properties or requirements of that emulsifier. This approach is very common in the small scale and artisanal scale. The other approach is the one that is very common in the mainstream industry and in the big industry. So you have some emulsion properties and requirements. This comes usually from the marketing department, that they want an emulsion with certain properties, and then the laboratory or R&D goes and searches for a suitable emulsifier that matches these emulsion properties or creates these emulsion properties. Again, here there is no better or worse. There are just two main approaches that they both lead to creating emulsions. With a given emulsifier, although the properties of the emulsion are predefined by the emulsifier, still you can, with a certain fixed emulsifier, slightly vary the viscosity. And here on this diagram you can see that it is a certain emulsifier. I think it was Plantasense, I'm not quite sure, but the emulsifier is the same, and we have varied some factors that cause the changes in the viscosity, and I'm going to explain them one by one. You need to keep in mind that what I'm going to explain and the factors I'm going to talk about, they are all for oil in water emulsions, which are the majority of the emulsions that we make in the cosmetic lab. Big part of the emulsions are oil in water, so these rules all apply to the oil in water emulsions. And this is the $1 million question, actually, how to increase or decrease the viscosity of an emulsion with a given emulsifier. The first thing is the procedure. This is not common in the big industry, so they don't change the procedure to change the viscosity. They rather use a certain procedure based on the emulsifier and the viscosity that emulsifier creates. But in an artisanal lab, you will observe it almost every day, depending on the mixers that you are using. Let's say you are using Kai Blendia versus bar mix versus a simple stick blender, an overhead mixer, an ICA homogenizer or Silverstone homogenizer. You will observe the difference in the emulsion viscosity if you swap your mixer, and you already perhaps have observed this difference. But in the mainstream and in the big industry, they don't change the procedure to change the viscosity. Here I have an example for you. This is a very low viscosity sprayable emulsion with lysolecithine, and we use the low viscosity emulsion because you can very easily observe the difference in the color. You may not observe the difference in the viscosity with naked eye and as you tilt the bottle, but you can see the difference in color, and keep in mind that the color is caused by the particle size. So here when we have a very rather intensive yellowish color, the particle sizes are bigger, and as the emulsion becomes lighter and lighter, here we have the smallest particle size, and it has a small impact on the viscosity, but it is quite obvious on the color. So we went to the microscope and made some microscopic photos from those emulsions, and here you can see the huge difference between the particle size from emulsion 1 to 6, and these are exactly the same formulation. We have just used different mixers to create the emulsion. The formulation is exactly the same, and these are varying. I think this was spatula or maybe one of the stick blenders up to here, which we had an homogenizer. And you see again here a difference, slight difference in the viscosity. It might not be obvious by observing, but when you measure the viscosity, you see the difference in the viscosity. So by increasing the oil phase concentration, again, this is about oil in water emulsions. By increasing the oil phase concentration, you can increase the viscosity of the emulsion. Now, keep in mind that each emulsifier has a happy range for oil phase. So you cannot take any emulsifier or all of the emulsifiers under the blue sky and create emulsions with 1% oil to 50% oil. It doesn't work that way. So each emulsifier has a certain range for the stable emulsions, and this is the information that usually the supplier delivers to you. For most of the emulsifiers, we have a happy range between 20 to 25% oil. For some emulsifiers go higher, up to 45%, and some emulsifiers have a happy range which is lower than that. For EcoGel, for example, the maximum oil phase concentration is 10%, but for, let's say, GSC, it is between 20 to 25%. So in that happy range, when you increase the oil phase concentration, you increase the viscosity of the emulsion, as you can see here on the diagram, and even on the photos you see from the back photo, the emulsion bowl in the back of the photo to the front, the viscosity is increased by increasing the oil phase concentration. Another factor is swapping the oil. By using different plant oils, you will have slightly different viscosities. It depends on the emulsifier and on the oil, and unfortunately there is no general rule which oil you shall take to create higher or lower viscosity. It really varies with the emulsifier, and you can, when you are making an emulsion, you can try to swap your oil between different plant oils and see if you can observe any difference in the viscosity. It definitely will have a make a difference and impact on the skin feel and on the flow, but sometimes you can observe a difference in the viscosity. Obviously, when you are using butters or semi-solid oils such as babassu oil and shea butter, you create higher viscosity. But between the liquid plant oils, there is no general rule that which one will cause a higher viscosity. It mainly depends on the nature of the emulsifier. By swapping the polarity of the oil or changing the polarity of the oil, you usually have a huge impact on the viscosity, on the skin feel, texture, and sometimes even on the stability. Again, here there is no general rule that polar oils work better than non-polar oils or vice versa. It mainly depends on the emulsifier, and usually this is something that the supplier doesn't give you any information. So this is again something that you need to experiment yourself. What I recommend is usually making a very basic kiss formulation. As I always mention, kiss, keep it silly simple, with a plant oil, let's say 20% of baobab oil. And then swap about 3 to 5% of that plant oil with oils with a slightly higher polarity and slightly lower polarity. So you take your first formulation has 20% baobab oil. Let's, if I can write it here for you, 20. Oh, so beautiful. 20% baobab oil, and then your second formulation contains, let's say, 17% baobab oil, and you are using 3% of green or an ester oil, isoamyl laurate, or even triheptanoin or squalane or other ingredients that have higher or lower polarities compared to the oil. And then you observe the changes in the viscosity, the changes in the skin feel, and in the stability, and you go for the combination that gives you the best results. So there is no general rule, but there is definitely the polarity of the oil makes an impact on the viscosity of the emulsion. The gum makes a huge impact on the viscosity of the emulsion. Here again we have a very basic formulation. We always start with a very simple kiss basic formulation, and we have 0.5% Solagum AX, which is a blend of acacia and xanthan gum, and then we have just removed 0.1% of that and replaced it with other gums, Tara gum, amigum, which is sclerotium, konjac gum, and you see the huge difference in the viscosity. You can even see that on the photo. This is the medium viscosity or low viscosity emulsion with Solagum, and here we went to a high viscosity thick cream. So by swapping the gum, by changing the gum, you make a huge impact on the viscosity of the emulsion, as well as on the skin feel, flow, and even sometimes stability. Even the method of gum dispersion and hydration, hot versus cold. The pink bars here are hot dispersion. Look how beautiful I can write. And the blue bars are the cold dispersion. So for the same gum, we have used either hot or cold dispersion. For some gums, it doesn't make a huge difference. For tragogans, it makes a slight difference. For Solagum AX, almost no difference. For Tara and sclerotium, it makes a huge difference. For konjac gum, it makes a huge difference. I didn't mention it, I didn't have it here in the diagram. You don't necessarily need to make emulsions. Even when you disperse the gum in plain water, you will see the difference if you are using hot water or cold water. So it makes a huge difference in the viscosity as well as in the stability. And if you don't know which gum wants or likes hot water versus which gum doesn't have any preference, hot or cold water, we have a free booklet available on our shop. It is skinchakra.eu. You go to the digital products and the technical ebooks. There is a e-booklet available that you can download, and you can see which gums prefer or need time and temperature for complete hydration, and which gums for them it doesn't make any huge difference if you are using hot process or cold process. You can use texture modifiers to change the viscosity. They definitely make an impact on the viscosity, on the texture, on the appearance, and on the skin feel. One of the texture modifiers that I use very often and I like it very much is the modified rice starch. You can use other types of starch, but they have slightly different properties and different requirements in terms of time and temperature, but the modified rice starch is the one that I very often use. Here again, a basic formulation. We went from 0% to 10% modified rice starch, and you see that the viscosity is increased. You can even observe it on the photo without any viscosity measurement. The color becomes slightly whiter and more luxurious, and the viscosity increases by applying the modified rice starch. Other viscosity or texture modifiers that we can apply are fatty alcohols. This is the cetyl alcohol, or waxes such as berry wax or miraca wax, or as I mentioned in the previous slide, using butters versus liquid oils. Now keep that in mind that this can sometimes backfire, so you don't go very high with fatty alcohols or waxes or butters, because it can have a negative impact on the skin feel and even sometimes on the stability. So you can apply about 1 to 3%, even sometimes 5% berry wax. It creates a very beautiful texture. But if you go higher, the skin feel will become waxy and the flow of the emulsion will not be that pleasant. So you just don't go very high with these viscosity modifiers. Again, my recommendation is start with a very low concentration, let's say 1%, and slightly go to about 5% to see which one gives you better results and better appearance, skin feel, all of that. At the end of the day, the emulsion is a combination of what you need with an emulsion. With an emulsion is the skin feel, the flow, the lack of tackiness, lack of soapiness, and lack of peeling effect. So you cannot just jump to, let's say, Tara gum or konjac gum and 10% berry wax to create a high viscosity emulsion, because you want to create something that is appealing to the feel as well as stable, but you need something that is appealing to the feel and to the touch, and actually fulfilling your requirements for the container, for dispersing method, and all of that should be considered when you are modifying the viscosity. Having said that, I thank you for your attention. I hope that you could take 1 or 2 useful points from this presentation, And I wish and pray that all of your emulsions stay stable and you can go and create stable, effective and safe emulsions in your laboratory. If you have questions, just type them in the comment of this presentation and I'll come back to you either with a written answer or create another presentation. I wish you all the best and a blessed day. Thank you for your attention and for your patience.